So for this lesson, we're finding the surface area of a prism and a pyramid. Technically, what you can do is just find the area. If you know all the basic areas, you could just find all the areas of every single face of your solid and add them up. More than likely, that might have been one technique that they taught you when you did this in 7th grade. Because this is a 7th grade skill. We are supplementing our textbook with this. So your homework tonight is not on big ideas. It is a PDF, but we're still going to use all of our basic areas in order to solve the surface areas. So let's go ahead and take a look at some vocabulary terms. Now, they may not have referred to the sides of your prisms or the sides of your pyramids as being a lateral area, but that's what it is here. The lateral area is just the sum of the areas of the lateral faces. Whenever I refer to lateral area, I'm going to use the abbreviation LA. Whenever I talk about surface area, another term that you can also refer to as surface area is total area. So I'm either going to refer to this as SA or TA. And all that is finding the areas of all of the faces, the bottom, the base, and then all the lateral area. Now, when it's a prism, there's actually going to be two bases, the top and the bottom, and then all of the sides. So you would just add them all up. So we're going to see on the next slide that formula is 2 times the base area, because it'll be like a top and a bottom, and then we'll add in that lateral area. Now remember, some of these solids may not be pictured sitting on their base. So sometimes, especially when it's the triangular prism, sometimes they tilt it and sit it on its side or its lateral face. So here are the formulas for lateral area and total area. Now let me go ahead and identify the pictures of these solids. So the top solid up here, this is actually a picture of a rectangular prism. Now this solid is the only solid that you can choose which rectangle is the base. A lot of times when I have a rectangular prism, I always choose the rectangle that it's sitting on as my base. So if I were to be doing this calculation, a lot of times I use the base that it's sitting on. But again, you could have chosen the front and the back or the left and the right side. Then the second solid that's pictured here, this is, notice you're looking for the shape that you have 2 of, and I actually have 2 triangle faces here, which would make this a triangular prism. Notice it's not sitting on its base. So again, what you're looking for to name the prism, you have 2 triangle faces, and then you have 3 rectangle or parallelogram faces. So technically what you could do here is find the area of each one of the faces and add them up, or you can use these formulas that I'm about to talk about. And then this bottom one, this has got 6 sides. It's actually a hexagonal prism. And in order to do this one, notice we have 2 hexagon faces, and that's why I named it as a hexagonal prism. And then we would have 6 parallelogram or 6 rectangle faces. And again, you can either use the formula or you can find the areas separately. We have a quiz on this a week from tomorrow. So this week, what we're going to do is spend 1 day on this. Then Tuesday and Wednesday, we will cover cones and cylinders, which will be back in our textbook. It'll be 11-7. We'll spend 2 days on that. And then on Thursday and Friday, 2 days on 11-8, which will be spheres. And we'll do surface area and volume of those. Then your quiz, we will review on Monday. and your quiz is the next Tuesday. So not tomorrow, but a week from tomorrow will be a quiz on these 3 sections. This one and then the 2 last ones from the textbook. Then after that, we'll start chapter 12, which will be probability. So now back to this. Now, in order to find the area of the hexagon, we got to reach back to our section 11.3 and remember that formula for area of a polygon. And this is what we would use for a hexagon. You can either memorize it as 1/2 apothem times perimeter, or 1/2 apothem times number of sides times the side length. So we will be bringing back this formula. In the homework tonight, I give you the A, the N, and the S. You will not have to do any trig to get the apothem or a side length, or you will not also have to draw any special right triangles. So everything will be given to you in all of the figures. Now, one other thing, I believe it's number 4 when you're doing the homework tonight. It's going to be a trapezoidal prism, and the formula for area of a trapezoid is going to be 1/2 base 1 plus base 2 times the height of the trapezoid. You'll need this formula for the homework tonight. So for the hexagon, it's a polygon, and we need this formula, which we learned in 11.3. Now, the formula here for lateral area, and again, I'm referring to it as LA, is going to be the perimeter of the base times the height of the prism. For total area, it'll be that lateral area plus 2 times the base area. Because again, you're going to have a top and a bottom, which is your base. So again, the pH here, this is my lateral area. So 2B plus LA. And again, you can either memorize it as SA or TA as your total area or surface area. Now, if you prefer, again, instead of using the formula for LA, you could find all of those parallelogram or rectangle sides and then add them all up. So my first example here, this is a rectangular prism. Now again, this is where you can choose which rectangle is your base. I'm going to use the one that it's sitting on. So I'm going to say this is my rectangle base. And notice it has a length and a width. So you could either say the 4 is the length and the width, or you could also say that this is the base and the height. So either way, in order to find perimeter of that base shape, that's what the capital P stands for, is perimeter. So it's perimeter of the base. So what I'm going to do here is add 4 plus 4 plus 2 plus 2, and I get 12 centimeters for the perimeter of my base. My base is a rectangle, so the capital B represents the base area, and it's a rectangle, so you can either do it as length times width or base times height. So 4 times 2, and it's 8 centimeters squared. And the formula for lateral area is going to be perimeter. So LA stands for lateral area. And that's going to be perimeter times the height of the prism. The height of my prism is this 6 over here. So this is the height of the prism, and that's the H I'm using right here. So I already calculated the perimeter back at the beginning of the box there. So my perimeter was 12. The height is 6 of the whole prism. So when I multiply that, my lateral area is 72 centimeters squared. So remember, any area calculation has the units squared. And now lastly, for total area or surface area, so again, TA stands for total area and SA stands for surface area. They mean the same thing. So that formula is 2 times the base area plus the lateral area. So my base area was 8, so 2 times 8, and my lateral area, I just calculated right above it, was 72. I'm going to get 16 plus 72, and my total area is going to be 88 centimeters squared. Back in middle school, they probably didn't teach you this formula. The formula they probably taught you was this one. 2 times the length times the width. Let me do it in a darker color. 2 times the length times the width plus 2 times the width times the height plus 2 times the height times the length. Something like that, where you have a top and a bottom rectangle, and that's why you multiply it by 2, and then a front and a back, and a right and a left. Or you could have also done them individually, added them, and then multiplied by 2. Technically, you can do this if you wish. You can calculate the surface area either way. All right, so this one over here is the picture. I know it's kind of hard to see. However, notice my base shape here is a triangle. The top is a congruent triangle. And notice if you zoom in here, this is the height of that triangle base is 2.8. And then I could also put the 4 here because these two 4s are the same, this one and this one. So in order to answer the first question, it wants me to find the perimeter of the base. So my perimeter is found by adding up all the sides. So 3 plus 4 plus 4, and I get 11 centimeters. Now for the area of my base shape is a triangle. So the capital B represents area of the base. So I'm going to be using the formula 1/2 base times height. So again, I could draw the same height here that is up above. And this is 2.8. So this is the height of the triangle base, and this is its base. So I'm going to be doing 1/2 4 times 2.8, which gives me 5.6 centimeters squared. Now for the lateral area, remember that's going to be, this is the height of the whole prism. And that's what I need for this H. So I'm doing perimeter times the height of the prism. So my perimeter was 11, and the height of the prism is 6. So the total lateral area is 66 centimeters squared. And now for total area or surface area, 2 times the base area plus the lateral area. My base was a triangle, and I found the base area to be 5.6. So I times that by 2, then add the 66. So I get 11.2 plus 66, 77.2 centimeters squared. This one was easy. They actually pictured it sitting on its base. A lot of times when you have these triangular prisms, they'll be sitting it on one of its lateral faces. They tend to sit it on one of the rectangles. So the next example, notice this one is not sitting on its base, but the base, the shape that I have 2 of, is a hexagon. So this is my base right here. It's a regular hexagon. So in order to calculate the information I need, I could first find the perimeter. So the perimeter, so let me label these numbers as well. So the 8 is the side length of the hexagon. The 6, remember, is not sitting on its base, so the 6 is actually the height of the prism. And the 7 is the apothem. So the 7, this is the apothem. I'll just call it A. So let's go ahead, and I need to find the perimeter of the base. So the perimeter of my base shape, it's a hexagon. So number of sides times side length, 6 sides times the side length, which is 8, giving me a perimeter of 48 units. Now notice this time it didn't give me the little chart and tell me all the things I needed to find. So what I'm trying to find is total area. So surface area or total area, remember, is 2 times the base area plus the lateral area. So let's go ahead and finish up working on my base area. So to calculate the capital B, I'm using the formula for area of a polygon, which is 1/2 apothem times perimeter. So my apothem was given to me, it was 7, and I just calculated the perimeter, and it was 48. So the area of my base is 168 units squared. Now I have to find the lateral area. So my lateral area, remember, is the pH, perimeter times the height of the prism, which is this 6. So my perimeter I calculated to be 48. The height of the prism is 6. So my lateral area is equal to 288 units squared. Now I'm going to take this lateral area and the base area and plug it in to the total area formula. So my surface area, or also known as total area, is going to be 2 times the base area plus the lateral area. So 2 times the base gives me 336 plus 288, and my total area is 624 units squared. So when you're doing the homework tonight, these problems involve a lot of calculations. Yes, I know you're using your calculator, but I still need to you need to show me how you're plugging it in to each of the formulas. Next, we'll talk about pyramids. So when we need to find the surface area of a pyramid, what we need to do is find the lateral area, and there's 2 methods. Notice in the pyramids, all of our lateral faces are triangles. So method 1 would be to find the area of one lateral face and then times it by however many triangles you see. Now, this only works when it's a regular pyramid. So in the case of this picture here, this would have been a regular pyramid, so it would be a square pyramid. And then all 4 triangles going up the sides would be all congruent triangles. So you find the area of one of the triangles and times it by 4. The other method would be to use the formula 1/2 perimeter times slant height. Now, we haven't seen any examples yet with slant height. We've always been only working with that height that was the height of either your prism or your pyramid. The slant height is actually the height of the triangles going down the sides. This is actually a lowercase l here, and you're going to normally see it as an italicized or lowercase letter l. So that's the slant height, and it goes down the side of the triangle. Now, again, we're going to see coming up on the last slide an example where it's not a regular pyramid. It's actually going to be a rectangular pyramid. And in that particular case, you're going to have to find all of the faces separately and add them up. And you're going to have that on the quiz. Here is now the formula to calculate total area. Now, notice before with the prisms, you multiplied the base area by 2, but this only has one base. And then it's got those triangles, which is the lateral faces, the PL. So 1/2 PL. Again, this is a lowercase, italicized letter L. So you're going to multiply 1/2 perimeter times slant height and add it to the base area. Now, if it is not a regular shape on the bottom, if it's not a square or an equilateral triangle or a regular hexagon or any other polygon, if it's not regular, you just have to find all the faces separately and add them up. Example 4. So here it says we have a regular square pyramid. Notice a picture is not provided, so I'm going to draw one. It always helps me. Now, whenever I want to draw a square pyramid, what I like to do is I draw a triangle, and then I draw a triangle to the side of it, and then I show the edges that are sort of in the back, and I use those as like dash lines because they're behind and they're sort of hidden from view. So this is my square pyramid. Notice it's telling me that the base edges are all 6, but it's giving me a lateral edge, which are going to be these things going down the sides. These are the lateral edges, and they're 5 centimeters each. The first question wants me to find the slant height. Remember, the slant height is this segment that goes down the side of the triangle. And again, you could pick whichever one you want. Now, what I'm going to do here is turn this into a right triangle. So what I'm going to be working with is this triangle right here. And once I draw in that height or that slant height, it bisects the 6 and it makes it 3 and 3. So I'm going to pull this one out. And I have 5 here. And then the 3 that was bisected. And now I'm looking for the slant height L. Notice this is the classic 3, 4, 5 triangle. But if you don't recognize this Pythagorean triple, what you need to do is Pythagorean theorem. So I'll do L squared plus 3 squared equals 5 squared. Square the 3, square the 5, subtract the 9. L squared equals 16. Square root it, and L equals 4. And remember, L is your slant height. So my slant height here equals 4. So this segment right here is the slant height. Next, for part B, it wants the lateral area. Now, technically what I can do here is find the area of this triangle right here and then times it by 4. That would be method 1. So for part B, method 1 would be to find the area of one triangle and then times it by 4, because there's 4 of them. So I would be doing formula 1/2 base times height. Once I get that area, I'm going to multiply it by 4. Notice my base is 6. My height, I just found, it's the slant height. And then I times that by 4. So I'm going to do the area here and then times it by 4. So once I do this whole thing, I end up getting, this will end up giving me 12 times 4. So my lateral area is equal to 48 centimeters squared. This was method 1. Method 2, so you can choose, or you could do method 2. And remember that formula was the 1/2 perimeter times slant height. So my perimeter, it's a square. So my perimeter is 6 times 4. So perimeter of my base, number of sides times side length. 4 sides in a square. Side length was 6. My perimeter is 24. I found the slant height to be 4. And if I multiply that, I still get 48. Same answer I got when I did the one triangle and times it by 4. So it's totally up to you which method you use. So this answer is 48 centimeters squared. For part C, I need to do the area of the base. Remember, your base was a square. So base area is 6 times 6, 36 centimeters squared. And now for total area, we're going to do the area of the base plus the lateral area. So for part D, total area, area of the base plus lateral area. Well, I did the base right above. It was the answer to part C. It was 36. And lateral area was part B. That was 48. So total area is going to be 84 centimeters squared. Now, for the last part, part E, if they had asked you to calculate the volume of this pyramid, we would have needed the height, not the slant height. So in order to do this, that's what it wants, is the length of the altitude. So remember, the altitude is here in the middle. So if I were to draw it, it's right here, and it goes up. And again, I'm going to do another right triangle. So let me pull that one out. Again, the 6 was bisected, so this is 3. I'm solving for the height. And then this thing that's coming down here is that slant height. It was the 4. Now, remember, in the 3, 4, 5 triangle, the 5 is the hypotenuse. So this is not my classic 3, 4, 5. I actually have to do Pythagorean theorem to get this altitude. So height squared plus 3 squared equals 4 squared. 3 squared is 9. 4 squared is 16. Subtract the 9 from both sides. My h squared equals 7. I don't want h squared, I want h. So square root it. So the height of this pyramid, or the altitude, is the square root of 7. And the only reason why you would have to go back and calculate the height is if it asks you to find the volume. Example 5, regular triangular pyramid. It's giving us the slant height. So that would be this height coming down here. So this, let me do it in red so it shows up in the blue background. This is my slant height. It's 9, so that's your lowercase italicized L. And then it told me that the base perimeter is 12. So the perimeter is 12, and because it says it's regular, that tells me all these sides in the triangle here of the base are all 4s. Now, in order to calculate lateral area, I'm going to use the formula 1/2 perimeter times slant height, because they gave me both of those from the beginning. So 1/2, 12 times 9, and my lateral area is 54 centimeters squared. Now the BA, that's my base area. I need to find the area of this triangle base here. So I'm going to pull it out because I need to find the height of it. I only have the base. So if I pull that triangle out, and it all has sides of 4, because it's equilateral, it's also equiangular. So all of these angles are 60 degrees. When I draw in the altitude, it's going to bisect that 4 and make each of these sides 2 and 2. It's also splitting this 60 here into 30 and 30. And I need to work with just one side of it. So 4 and a 2, this was 30, 60, and then the right angle. So remember, this side is x, this is 2x, and this side across from the 60 is x square root 3. So I already know x, it's 2. So this side, or the height of my triangle, is 2 square root 3. So now to do the base area, part B, so base area, BA, which is part B, I'm doing 1/2 base times height, because it's a triangle. So my base is 4, and my height, I just found it, 2 square root 3. So 1/2, 4 times 2 square root 3, and this ends up giving me 4 square root 3. And these would be centimeters squared. So that is my base area, 4 centimeters squared. So now total area, we have 1 triangle base plus the 3 triangles for the lateral area. And I just calculated both the BA and the LA. So the base area was 4 square root 3. My lateral area was the 54. And if it said to leave it exact or simplest radical form, that would be your answer. If it says round to the hundreds place, then I would have to multiply 4 times the square root of 3 and add 54. And you would get 60.93 centimeters squared. Remember to use all the formulas I just showed you, that base shape must be regular. Notice this is not a regular quadrilateral, it's a rectangle. So in order to find the total area here, I'm going to need to find the area of the base, which is a rectangle, and the 4 triangles that are forming the lateral area. So in order to do this, I'm going to be taking so to get the total area, I need to find the area of the base. So in order to get the total base area, the total area of this pyramid, we need to find the area of the base. And my base shape is a rectangle here. So I'm going to find the area of this rectangle. So I'm going to do 11 times 5, and that's going to give me 55. Then the next thing I want to do is find the area of the triangles that are going to be forming the lateral area. So the first thing I'm going to do is I could do, say I have a front and a back triangle. So I'm going to find the area of the front triangle and the area of the back triangle. So for example here, this could be my triangle here. That could be my front and my back. So notice it's got a base of 11 and a height of 10.3. So what I'm going to be doing is 1/2 11 times 10.3, and that's for both of them. They're both the same. So once I multiply this, I get 56.65, and I have 2 of them, the front and the back. So I'm going to add this in twice, or you can times it by 2 once you find one of them. Then I also have to find the left side and the right side. Now you can name these whatever you want, but you're going to have congruent triangle pairs on the top when it's a rectangle. So then now what I need to do is the area of the left side and the right side. So the left triangle and then the area of the right triangle, and they're the same. So then that is going to be 1/2 and its base is 5, and its height is 11.4. So 5 times 11.4. That's going to be for the front and, or the left and the right. Once I get that number, it's going to give me 28.5. So then I'm going to add that up here, 28.5 plus 28. So then now all I'm going to do is add up all these numbers. Oh, I should have put them here. So once I add all of that up, the 55 plus the 56.65, 56.65 plus 28.5 plus 28.5, I get 225.3 yards squared. And that will be the total area. So basically you're finding the rectangles and adding them. Front and back, you'll have 2 congruent, left and right, 2 congruent triangles, and then add it to the rectangle base.